Right, so Aisha, can you hear me? Can you hear me? Just call me if you can hear me. Call me. Call me on my line so I can start the class. Okay? So it shouldn't be like what happened last time. So just call me on my line if you can hear me and just start the class. I think you have my number. Please quickly do, let me confirm if you can hear me. Alright, so we're going to look at what we call what now? Circuit theory. Okay? So before we do that now, let us describe the properties of the circle or key facts about the circle. Now, here, take note. This is the circle. This is the center of the what now of the circle. All this part, we call it what now? Circumference. So circumference is the distance around the circle. So this space, everything here is called circumference of the circle. Everything. So the first one is circumference. Circumference. So now a line drawn from what now? From the center of the circle to touch any part of the circle is what we call the radius. So this one is the radius. That line is the radius. This line is called the radius. A line drawn from any part, center of the circle to touch any part of the what now? Circumference is called the radius. If I draw one line from this space to this space should be called the what now? The radius. Why? Because it's a line drawn from the center of the circle to touch any point or circumference. Now, suppose I label this space A, I label this space B, are you with me? From here to here is what we call an arc. So an arc is just a part of the circumference. This space to this space is an arc. From here to this place is also an arc. So an arc is a part of the what now? Circumference of the circle. So look at this. Arc is the part of what now? Of circumference of the circle. If I now draw a line, it's not private. Private. If I draw a line from this place to this place, we call it a chord. This is P, this is what now? Q. So a line that touches 2 points on the circumference of a circle and divides the circle into 2 unequal parts is what we call a chord. This place is a segment which we call minor segment. Minor segment. Then this big place is what we call the major segment. So let me draw it. So if I have P here, I have Q here. This place is the minor segment. Minor segment. This whole place is what we call the major segment. And this one is what we call a chord. So this line is what we call a chord. So a chord divides the circle into 2 parts, 2 unequal parts. Or we can say into what now? Segment. This part is what now? This part here. This part that has what now? An arc and a what now? A chord. Are you with me now? An arc here and a chord. So we can say a segment. The segment is equal to an arc and a chord. Take note of that. Are you with me now? So a segment is equal to an arc and a chord. Okay? So that one is clear. Now, if I now draw a line that passes through the center of the circle, a line that passes through the center of the circle, and divide the circle into two equal parts, that line is called a diameter. This line is called a diameter. So a diameter is line that divides circle into two equal parts. From here to here is a radius. From here to here is also a radius. So what is the relationship between radius and a diameter? You can see that from this radius, two radius form what now? One diameter. You can say diameter is equal to what now? Two radius. So radius for radius give us what now? Two radius to have a diameter. Okay? So diameter is equal to what now? Two radius. Any other thing? Yeah. Now, what forms something like a pie is what we call a circle. This thing. This piece. Look at this. Something like a pie. This is the radius. This is the radius. This is what now? An arc. Everything here is what we call a circle. So a circle is the combination of what now? Radii and an arc. Why a segment is the combination of what now? A chord and half. A sector is combination of radii, that's two radius, with what now? An arc. Segment is an arc and a chord. Is it clear? So here we have what do you call it? Minor segment, major segment. AB, minor arc. AB here, major arc. Look at this. Look at this. Small AB here. This one, this AB, is what we call the minor arc. And this big AB here is what we call the major arc. Major arc. So what is that? Then what is the circumference of the circle? Look, say circumference is the distance around the circle. Circumference of the circle has the formula 2.5. That's the formula for the circumference of a circle. So I think enough of that. Let us now discuss what now the major thing that we want to discuss. But before that, these are the key things that you must know as far as the circle is concerned. So let me just write this one up. Let us start from the first theorem. Theorem 1. Theorem 1. Angle at center is equals to 2 times angle at circumference. Angle at center is equal to 2 times the angle at the circumference. That's the first theorem. That's the first theorem. Theorem 1. Theorem 1. Theorem 1. Angle at center. Angle at center is twice angle at circumference. Okay? That's the first theorem. Now look at the diagram. If I have a circle like this is what now? This is the center. Or let me put the center here. You always see this letter being used to represent what now? The center of the circle. So O is the center of the circle. So this is an arc A, B. Now see the rule. Under circle theorem, what you must is first 2 points to form an arc. Please listen to this carefully. You use first 2 points to form an arc. Then those 2 points will now travel to meet at a point. The 2 points that work initially You trace them to meet at the point. Once they meet at the point, they intersect. Okay? An angle will form at their point of intersection. So you're only just to what now? Spot the 2 points that are traveling. Spot 2 points that are traveling. Where did they travel to? That's another question. Did they travel to the center? If they travel to go and meet at the center, it means angle will be at what now? Center. If they travel to go and meet at the circumference, it means angle will come at what now? Circumference. So your own is just to spot 2 points to form an arc and make them to travel either to the center or to the circumference. So here now, this is the first point. So I'll be able to form an arc here. This one will travel to the center. So I will travel to the what now? The center. Because they met here, an angle will form here. Are you with me? An angle will form here. Let's call this angle what now? Let's call it angle. Let us go. An angle will form here. Suppose I call this place P. This is the remaining part of the what now? Circumference. This thing now too, now travel. This point travels here. This one to go and meet it. So this arc forms another angle at what now? At the circumference. Center, circumference. You say angle at center is twice angle at circumference. If x is the angle at what now? Circumference. This one must go up now? 2x. Take note of that. Angle at center is bigger than angle at what now? Circumference. How much? By 2. Are you with me? So angle at center is twice angle at circumference. We can have it like this. We can have equally have it like this. The way is just to work now. Spot the work now. The arc AB travels to this point. Travels to this point. And now we form here. Center. You can go here. You can hear the travel. This one here travels to this place. This other part will go and meet it to form an angle here, angle x. This angle here becomes what now? 2x. Angle at center is twice angle at what now? Circumference. Angle at center is twice angle at what now? Circumference. This one is what now? Point P. Okay? Your own, like I told you, is just what now? Get the 2 points that point an arc. See the way they travel. They travel to the center here, comes back, travel the what now? Circumference. So this is at center is twice angle at circumference. Now we have equally have it like this. See, where's the arc? A and what now? And B. This arc travels here, center. This arc travels here, circumference. Now be careful here. If this place is x, okay, this angle here will be 2x. The one outside is the angle of what now? At center. Circumference, center. Circumference, center. Be careful here. Okay? This is what now? Center. So angle at center is twice angle at what now? Circumference. So if I want to get this angle here, I'm having two angles at center. I'm having the real angle at center and equal angle we call reflex angle at the center. So the angle here, since we know that what now, some of angles at the point is 360 degrees. This one now because of what? 360 minus 2x. 360 minus 2x. So these are what we can have. Under what now? Angle at center is twice angle at circumference. So take that before we solve the question. That's the first here. So let us go for questions. Let us go for questions. So the first one, we have this diagram. Let me wipe this one off. Have you taken notes of this? You can watch the video. You can watch the video. So just take the diagram. Can I continue? Let me give you time to take the diagram down. So let me get to the first one here. Let me change the second one too. So I'll give us what now? The question. Can you use the question? So look at this first one. Now this. You can place any direction. It doesn't really matter. Now it's just what spots they are and see where they are traveling to. This one is what upside down. You put X here. You put 58 here. Also find X. You can see diagram. You put 3y here. You put 75 here. Find y. Is 0 is parallel to the center. And it's supposed to 0 goes through the center. Look at another diagram. M is here, N is here, and 65 degrees is here. Then, the last one is on this. What is that? No. So let me write one off. See this contains. Okay. Then is what I can do to that. Value. Or I have this. I have this. I have this. There's an angle here being extended here. This is 146 degrees, 146 degrees. Now I have an internal what now? Internal this. This one is center. You put B here, C is here, and A is here. So we have to find what now? A, B, C. So let's solve these 4 questions. We'll go to the next one now, next year. So the first one, this is question number 1, this is question number 2, this is question number 3, and this is question number 4. So let us go to the first one. The first one here, we have what now? Angle at center. So the theorem is what? Angle at center, angle at center, angle at center, because 2 times angle at circumference. Put an angle at what? Circumference. So where's the angle at center? X is at the center. So here I'll put what now? X equals to 2 times, where is circumference? 58 is circumference. So 2 times what now? 50 what now? 58. So our X is equals to 6 times 1, 1 what now? 6 degrees. That is question number what? Question number 1. Clear? Alright, so let us go to question number 2. Now, same rule. Angle at center equals to 2 times angle at circumference. So we have equals to 2 times angle at circumference. 2 times angle at circumference. So where is the angle at center? 3y is the angle at center. So we have 3y, angle at center, 3y. Equals to 2. Where is the angle at circumference? So the 5. We have to times what now? 75 degrees. So we have 3y. Can you divide 2 by what now? This is 150, okay? 3y equals what now? 150. So ordinary y may not be 150 over 3. 3 will cancel 3, or y will just work now. 5 work now. 5 50. And when we put 3 times 50, that is 150. 75 times 2, it goes what now? 150. Because angle at center is always twice. Please don't miss that thing up. Angle at center is twice the rule. The angle at center is twice angle at half the circumference. So let's go to the third diagram. Number 3. So let me write this one out. So what I want to slow down the thing. Number 3. So look at this. This is the center. M is the center. Then 65 is the circumference. You see that diagram? You can have multiple diagrams, but bring what now? Multiple diagrams in one circle. Multiple arrows, multiple lines in one circle. You're only just to spot the arc, see where you are traveling to. Look at the arc. Where is the arc? I have this arc here, I have this point here. This is the arc. This arc travels to the center here to form M, comes back, travels to the circumference to form what now? 65. So you see how angle at center equals to 2 times angle at circumference. So where is the angle at center? M. Where is the angle at circumference? 65. So we have 2 times what now? 65 degrees. And for M, because what now? 0, 130 degrees. The same thing. Center, circumference. You see that? M center comes back. The same arc carries this N, the circumference. So you see how our what now? Our N equals what now? 2 times what? 65 degrees. So N equals what now? 130 degrees. So angle at center is twice angle at circumference. Is it clear? Alright, good. So let us continue. There are 4. I'm just going to write soon up. Question number 4, be careful here. This triangle extends outside. Okay? This triangle extends outside. So we have something like this. So let me give you the bigger picture. Good. We have this. We have this. We have this. This is now 1.6. Center. B. C. And A. Now, you are going to see that A is the center. This place will be the what now? Circumference. But this one was not given, but we need this place to get this one. This is 146. This is a straight line. Okay? It's not in one case that the diagram will go now complete. You can always improvise. You can add what and what that you need to make the diagram work now to be complete. To make the job to work now effective. So this is the center. This is the what now? Circumference. But this circumference was not given. Center was given. Circumference was not given. We were given this one for the 6 to use to get what now? This circumference. This one and this one, they are angles on a straight line. So I can put X here. I will not say S plus 146 equals to what now? 180. What's the reason? Sum of angles on the straight line. Sum of angles on a straight line. Okay? So what happened here? It means our X will be equals to 180 minus 146. And how it goes what now? Here, that is 4. So what now? It's what? 34 degrees. 34 degrees. So our S is what now? 34 degrees. A is the center. S is what now? Circumference. I will now use this one. Angle at center A A angle at center equals 2 times angle at circumference. Where is angle at circumference? X. So 2 times what now? 2 times x. And mind you, our x is what now? 34. This will now be equals to 2 times what now? 34 degrees. And this will be also what now? 68 degrees. So our A is 68. So now need what now? B and C. Mind you, we said a line drawn from the center of the circle to touch any point of circumference is the radius. So this space is radius, this space is radius. In that case, this line and this line, they are the same thing. So if I have two sides of a triangle to be the same, that triangle is what we call isosceles triangle. Look at this. So all these things are very important. This is triangle, this space, and this space they are equal. If they are equal, this angle here and this angle here, they must be the same. This is what we call isosceles triangle. Isosceles what? Triangle. Then you say the base sides of an isosceles triangle, then base angles of an isosceles triangles are equal. The base sides are equal, the base angles are also equal. So this one is x, this one is what now? X. This one is y, this one is what now? Y. So in this case, it means our B and C want the same thing. B is equal to what now? C. So we have B equals to what now? C. What's the reason? What's the reason? Base angle of an isosceles triangle. Do you know why I call it triangle? Because this is the radius. Radius is here. Radius is here. Same thing. A line of the center of the circle to touch any point of circumference. Radius. So this thing makes this one to be what now? An isosceles triangle in a circle. So we are having this plus 180. Sum of angles in the triangle. So we have our A plus B plus C equals to 180. What's the reason? Sum of angles in a triangle. Oh yeah, consider our what now? Our B equals to C. So I can use what to work now to B. So now that A plus B equals to what? 180 degrees. So what are A? Our A is what now? 68. So that's 68 plus 2B equals to what now? 180 degrees. So now having 2B equals to what? 180 minus 61 minus 68. 2B give us here 2, 1, we have what now? 112. 112 degrees. So what about our B? Our B equals to what now? 112 over what now? Over 2. Now equals to what now? 2 here, 5. We have what now? Number 1. 2 in 12. That is 6. So if B is 56, C too will be 56. So A equals to what? 68. B equals to 56. C equals to what now? 56. And when you add everything, you have 180. Is it clear? So what is that? On that. Yeah? So just write the question. Write the solutions down. Alright, so let's go to the next theorem. Theorem 2. Theorem 2 is what? Angle in the same segment. Angles in the same segment. Theorem 2. Angles in the same segment. I'm going to give you 4 theorems today, but I just raised on some questions from there. Theorem 2. Theorem 2. Theorem 2. Angles in the same segment. Angles in the same segment are equal. Angles in the segment are equal. What do you mean by this? It means it is the same arc that guides the two angles to the what now? Circumference. Look at what I'm saying. See it down. This is our circle. This is center. This is our arc. Okay. This arc. Okay, let me do it like this. Where is that? A, B. At AB, you give it 0 here. At AB, carries ACB to the circumference and angle ACB to the circumference. So this angle here is a circumference. This angle here is a circumference. Because they are being carried by the same arc, they are in the same segment. Angles being carried by the same arc are said to be in the same segment. So is this AB that carries C to the circumference? This same AB carries D to the circumference. So in this case, we say angle ACB equals to angle ADB. Angles in the same segment are equal. Angles in the same segment are equal. Angles in the same segment are equal. So let me read 23 and 24. We're not solving that question. Solving that question. Okay? Solving that question. Let's go. Let's go. On 31. Angle in a semicircle is 90 degrees. Angle in a semicircle is 90 degrees. Angle in the semicircle is 90. So we have this 73. Angle in a angle in a semicircle is 90 degrees. So, how will this angle be formed? We have this. You see a what now? Diameter here, the is 0 here. This is center. This is the arc, AB. It is this arc that will now form the angle of what now? Circumference. Look at this. Once that arc is on what now? The diameter. The angle that will form to the circumference because what now? 90 degrees. So this place is what now? 90 degrees. So I can call this place P. So this angle APB or BPA. The owner of the angle is always at the center. You name it at what now? At the center. So angle what now? Angle APB equals to what now? 90 what now? Degrees. And APB equals to 90 degrees. Then theorem 4. The opposite angles of a cyclic quadrilateral are supplementary. The opposite angles of a cyclic quadrilateral are supplementary. What meaning? At least add up to my 180 degrees. At least add up to 180 degrees. When you have a quadrilateral, a four-sided shape, whereby all the vertices, okay, touch the circumference of the circle, we call it what now? A cyclic quadrilateral. Look at the diagram. These are circle. This is what now? The quadrilateral. So that this one is not to what now? Angle at center. Because of angle at center. But the only difference is what now? Under angle at center, and angular circumference. We have this. It's not all the vertices that touch the what now, the circumference of the circle. Just 3 of them, 1, 2, 3. But in case of what now, a cycle of that, all the 4 vertices must what now? Touch the circumference of the circle. Are you with me? This one, just 3. So is angular center is twice angular circumference. This one here. But this one is what now? Is cycle to natural what now? Theorem. So if I put this one to what? A, I put this one as B, C, and D. So I'm saying angle A plus C, angle A plus angle C equals to 180. Angle B plus angle D equals to what now? 180. The opposite angles of a cyclic quadrilateral are supplementary, meaning they add up to 180 degrees. So let us say it out here. So this angle A, okay, I want to name this angle A. How do I name it? B A D or D A B. So angle B A D plus, I want to name this angle C to be B C D or D C B. You must know how to name the angles. So plus what now? Angle B C, angle B C D, and plus what now? 180 degrees. Similarly, let me name this one A B C. Angle A B C plus angle A D C, angle A D C, and plus what now? 180 degrees. So you can take the maybe theorem. I can take you to have 4 theorems today and some questions on them. So in total, we have like 8 theorems. 7 or 8 theorems in total. So we're taking 4 today. So in the next, I'm going to take what remaining 4 theorems. Write these ones down and solve questions on them. Solve questions on them. Are we done? Are we done? So take this theorem and let's solve it now. Now, when solving questions under circle theorem, like I told you, you're going just to spot the point. 1 point here, 1 point here to form what arc. After you form the arc, then allow the arc to travel. The arc to travel to go and meet at the point. You now ask yourself, that point that the arc where they intersect, is it at the center or is it at the what now? Circumference. Are you with me? So spot your arc, 2 points that are traveling. Traveling arc forms a point. Traveling arc forms an angle. Traveling arc forms an angle. So we have Tapa. Okay? Traveling arc form angle. Traveling arcs form angle. Traveling arcs form angle. So the question now is, that angle form, is it at the center or is it at the what now? Circumference. So the whole idea behind circle theorem is this: arc must be traveling for this one first. So is the arc traveling? Yes, it's traveling. That traveling arc, where they meet, is it at the center or is it at the what now? Circumference. If they meet at the center, angle will form at the center. If they meet at the circumference, angle will form at the circumference. So let us solve the question. Let's solve one question. Let's solve one question. So let me write this one up. I'm giving you 4 theorems. So see this question. See this. This is what now? We put, meaning this is what now? The center. This is the center, diameter. This one came here. This one came here. Okay? One goes here. One here. You see it? Yeah, give me different diagrams like I told you. You will just put what? You will just take get your eye and strike it. Get the head and strike it. That's all. You put A here. You put B here. You put C here. 38 is here. And this place 35 is here. This place 35 is here. And that's to find A, B, and C. Look at the diagram. Look at the diagram. Okay? Now, we are going to solve the question based on the terms that we have right now. Okay, I'll send the diagram. Angle in the semicircle is 90. So this is the diameter. This diameter, this is an arc. This is the arc now. Travels to the circumference. If the arc is traveling from what now? From the center of the circle, the circumference. Angle in the semicircle is 90 degrees. So if this is our A, let me put here. A equals to what now? 90 degrees. You must tell them the reason. What's the reason? Angle in a semicircle. You can solve question under what now? Circle theorem, not only a one directional question or solution rather. But you can solve it the way you see. The first one that you see, the first diagram I can just picture out. Trying to solve the question. Okay, so the first one I picture out is what? Is my A. Okay. Okay, what's the next thing I can do here? If A is what now? A is 90. What about B? B will go to 92 because this is the diameter. Then travels to what now? The circumference. So A equals to B. B equals to what now? Okay, so let me just put it here. So A and B are equal. And again, angle is the same segment. Because it's the same arc. This arc that carries B, the circumference, comes back, carries A and B to the circumference. So our A equals to what now? Equals to B. Which is what now? The same theorem. Same theorem. So A equals to B. A equals to what now? B equals to what? 90 degrees. So remaining what? C. It remains C. Okay? Okay? Okay. Now look at this. This is a point here. 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 So this is a cyclic lateral. All the four vertices touch the what now? Circumference of the circle. So it means this and this one and this one, they are opposite sides of a cyclic lateral. This and this, opposite side of a cyclic lateral. Is it clear? So look at this. A and what is here? Okay? Opposite side of the cyclic lateral. Can I clear that thing out from here? Can I clear that thing out? Okay, 1, 2, 3, 4. Even B and this opposite side of what now? Cyclic lateral. So what is this case? This is what now? 90. 90. But look at it. Angle is semicircle. Diameter. Circumference. This is automatically what now? 90 degrees. 90 degrees. So now this plus this plus this. That's angles in the triangle. Are you with me? This and this angles in the triangle. And sum of angles in the triangle is what now? Is 180 degrees. So we can say our C plus 38 plus 90 because of what now? 180 degrees. What's the reason? The give you the reason. Sum of angles in what now? In the triangle. Sum of angles in the triangle. How to shall we? So we have what? Sum of angles in a triangle. So what do I have here? C plus 8. 9 plus this 112. 180. 0. So we have our C also what now? 180 plus 121 and 128. That will be 2. That will work now. So our C equals to what now? And the 2 degrees. So 90, 90, 90, the 2 degrees. So that's the answer. So just take solution down. Take solution down. And let us solve the last question. Let's solve the last question. Take solution down. Then I will solve one question and I will give you one more theorem. I'll solve one question and I will give you one more theorem. Look at this. Let me write this one. So we have this. We have this. We have this. We have this. Give us 90 degrees there. We have this. We have this. We have this. We put out this is center. So this is what now 21 degrees. This is W. This is X. This is Y. Okay, let's do that this way. This is what? Center, this is Y. And this is Z. So find W, X, Y, Z. Find W, X, Y, and what? And Z. This is diagram. See diagram. You have a complex diagram. Your only just to support the art. Support the art, then allow them to travel. Okay? Support the art, allow them to travel. It's very key. So, can I support any art here? Yes. This one and this one is an art. Then intercept, why traveling? This one goes here, this one goes here. The intercept, I can use that. The art that you want to choose, they must travel and meet at the point. Look at this. This one and this one. These are now. They meet at any point. This one goes here, this one goes here. I can't use that. They meet at any point. This one and this one is an art. This and this is an art. Then at any point, yes. This one goes here, this one comes here. So an angle is from here, angle at center. Angle at center. Z at center. You see it? Y21 will be at circumference. Look at it. This arc here comes back, travels to the what now? The circumference. So angle at center, Z, angle at what now? Circumference. If I should move all these things here, you see it. Let me remove all this picture here, you see it very well. You see it? You see it now? You see it? Remove this. Remove this. You know what I'm saying now? Angle at center, circumference. Center, circumference. So you will be able to work now to do what we call analysis. You break it down. Okay, pick this one, pick this point, allow them to travel. Now, circumference. So let me draw it down. Back, go, check this one. W. You see it now? You see it now? What do I have? X is equal to X. So what is the first thing? The first thing is W. This is triangle. This plus this plus this will give us what now? 180. And what's the sum of angles in triangle? 180 degrees. So we have this. We have this. So our what? W plus 21 plus 90 give us what? 180 degrees. See, this symbol is what? 90. This time is 90. So what's the reason? You must give us reason though. Sum of angles in a triangle. So now having W plus 1. That's what now? 180. Our W we just work on 180 and 111. So this will just work on 9, 69 degrees. But this 9 degrees. The next one to get it work now, Z. And I say Z. Or can I get X? Okay. WX. Okay, let me get X. This and this. What theorem is connecting this and this? Cyclic. Point 1, point 2, point 3, point 4. Cyclic and that theorem. Look at this. Look at this. Look at this. Cyclic and that theorem. So these are what now? Our X plus what now? X plus 21 degrees. Also what now? 180. What's the reason? Opposite angles of a cyclic quadrilateral. I can say what now? My x is equals to x is equals to what? 180 minus 21 degrees. This is equals to what now? Here 9. This is 5. 189 degrees. What's our x? So let us take that down. This is that now. So let's take them back. From goes here. From comes here. From comes here. This is this. These are W. These are Y. That's Z. This is the C. That's that. So I'm done with what now? X and what? X and W. What's the next one? Y center into 1 circumference. So our Y equals to what now? 2 times 21. 2 times 21. What's the reason? Angle at center equals to 2 times angle at circumference. So this is our y equals to what now? 2 42 degrees. Y equals to 42 degrees. Y and Z. Y and Z. What is the relation between Y and Z? Angles at the what now? At the point. Angle at the point. Angles at the point. So can we go? Can we go? Yes. So we have Y plus Z equals to 360 degrees. Y plus Z equals to what now? 360 degrees. What's the reason? Angles at the point. So what's our y? Our y is 2. Z, that's what 360 degrees. So Z now be 360 minus 21.2. What do I have here? Our this is 8, 1, 318 degrees. So that's it that. That's it that. So our x is what? So write w x y and z. Our w is what? It's 9. X is 159. Y is 72. Then let's do what now? 3, 1 into what? 1 into 2. Is it clear? Clear? So, what is that about? So when I give you what? The last theorem for today. Last theorem for today. Good. Take time to answer the short. So let's take the last one. So let me take the last one. Let me take the last one. I still happen to be side conductor is equal to the angle in the alternate segment. It's down to side conductor, right? Look at this. You have a diagram like this. I'm a side conductor like this. And now up on the exterior angle that is taken out. If this base is x, this piece goes to x. You know the reason? Suppose this one is what now? 70. This will be what now? 1 what? 150. Because this is a straight line. Sum of angle in the line is what now? 180. This one is 70. This one will be 110 rather. 70, 110. This is what now? 180. Opposite angles of the work now. Side conductor. So this one is 110. This one will work now 70. Please, exterior angle to a side conductor. Exterior angle to a cyclic collateral is equal to the opposite interior angle. Opposite interior angle. That's theorem what now? Theorem 5. Theorem 5. So out of this theorem, I'm giving you what now? I'm giving you 5. So exterior angle to a cyclic collateral is equal to the opposite interior angle. So this one is x, this one is y. Let me extend this one. Let me extend this. Suppose I extend this one and I put what here? Y. Where will be our y? This one. This will be our y. So this is equal to what? What's the y? 10. What is this? 170. 170 is also gives what? Opposite arms of the circle direction. So 10, 170. 170, 10, 170. Is it clear? So that is not just one question on quality day. That's one question on quality day. Are we ready? So let's go. So once you learn something in this class, let me know, please. You just send me a message on WhatsApp that you understand the class and you learn something in the class. So I'll send those to you. The last question I sent to you, you're not going to under what now? Under high energy and pressure. The test I sent to you, you didn't do it. Or maybe you've done it, I didn't send it to me back, please. I need that, it's very important. So what do you have here? Let's go here. How this, and how this. Now it's 10 seconds. To give me 80 degrees here. How do we define what? X and Y. Find X and Y. Very easy. And I use that theorem to solve this. This one is 80. 280. 80 plus Y is what now? 180. That is opposite arms of what now? Cycle to that one. This one is what now? 180. So this one is 80 to what now? 100. As simple as that. So let's solve it. I'll first say y plus 80. What's what now? 180. What's the reason? Angles on a straight line. Angles on a straight line. Straight line. So these are what? Y plus what now? 180 plus 80. And that was what now? 100 degrees. But our x plus y, what's what now? 180 degrees. What's the reason again? Opposite angles. Opposite angles of a cyclic quadrilateral. These are what now? X plus 100 plus what now? 180. What now our x? X will be equal to what now? 180 minus 100. And what is it? 80. Okay, let's use this theorem straight. This x is external to what now? To this 80. This x is external to this what? This 80. So that is that and that. So I hope you enjoyed this class. So that's that and that. Okay, so me what now? Like 5 theorems. The first one, angle center is twice angle circumference. Second one, angle in the same segments they are equal. Third one, angle in the semicircle is 90 degrees. The fourth one, the opposite angles of a cyclic quadrilateral are supplementary, meaning they add up to what now? 180 degrees. And the fourth one, exterior angle to a cyclic quadrilateral is equal to the opposite interior angle. Till we meet next time, God bless you. Bye bye.